Here is the equation that has started more furious internet arguments than almost any other in mathematics. 0.999, with the 9's repeating forever, is equal to 1. And let's be clear about the claim. Not approximately 1. Not almost 1. Not close enough for practical purposes. It is exactly, identically, the number 1, the same number, just spelled two different ways. The first time you hear that, something deep in your gut revolts. Surely, it insists, those 9's must fall a hair short of 1. Surely there's a tiny gap left over at the very end? But here is the quiet secret. You have believed this your whole life. Every single time you've written 1/3 as 0.333, you already signed up for it, you just didn't notice. So let's settle it properly. We'll prove it 3 completely honest ways, with a pizza, with a single line of algebra, and with the number line itself, and we'll go hunting for that imagined gap. Let's start with lunch, because this proof you can taste. Take a pizza and cut it into 3 perfectly equal slices. Each slice, plainly, is exactly 1/3 of the whole pie. Now write that 1/3 as a decimal. Divide 1 by 3 and you get 0.333, marching on without end. Your calculator shows you exactly the same thing. Now slide the 3 slices back together. You obviously get the 1 whole pizza you started with. 3/3 make 1 whole, nothing remotely controversial about that. But each of those 3 slices is 0.3 repeating. So 3 slices is 3 times 0.3 repeating, and 3 times 0.3 repeating is 0.999 repeating. It's the same 3 slices either way, so it's the same whole pie. Which means 0.9 repeating and 1 are simply the same pizza. Proof 1, served with lunch. Proof 2 is a single line of algebra clean enough to do on a napkin. We start by giving our mystery number a name. Let x stand for 0.9 repeating, whatever it turns out to be. Now multiply both sides by 10. On the right, multiplying by 10 simply shifts the decimal point 1 place over, so 10x becomes 9.999 repeating. Here is the crucial observation. Both numbers, the 9.9 repeating we just made, and our original 0.9 repeating, carry the exact same endless tail of 9's after the decimal point. So subtract the original from 10x. Because those infinite tails are identical, they cancel each other perfectly, leaving nothing at all after the decimal point. 10x minus x comes out to simply 9. And on the left, 10x minus x is just 9x. So 9x equals 9, which forces x to equal 1. The thing you insisted on calling 0.9 repeating was 1 all along. Proof 3 needs no algebra whatsoever, just one simple fact about the number line. Take any 2 different numbers you like. There is always another number sitting somewhere strictly between them. The easiest one to grab is their average, which always lands exactly halfway in between. 2 genuinely different numbers can never be jammed right up against each other, with absolutely nothing in the middle. So let's apply that test here. Name me a number that is bigger than 0.9 repeating and yet still smaller than 1. Go ahead and try to find one hiding in that supposed gap. You simply can't. There is no such number anywhere. Everything you reach for is either still down among the 9's, below our number, or it has already arrived exactly at 1. Nothing lands in between. And 2 values with nothing whatsoever between them are not 2 values, they are 1. So the gap you imagined isn't merely tiny. It is exactly, provably, 0. So why does it stubbornly feel like it never quite gets there? Because we secretly picture a journey 0.9, then 99, then 999, forever creeping up toward a wall at 1. And it's perfectly true that every stop along that journey falls a little short. 0.9 misses 1 by a tenth. 0.99 misses by a hundredth. Each step is still short of the wall. But here's the subtle thing. 0.9 repeating is not the journey. Those 3 little dots don't mean keep on walking forever. They name the destination that the walk is heading toward. And that destination, what mathematicians call the limit, is one single, exact number. The one and only place all of those steps are closing in on, with no other candidate, is 1. The individual steps, taken one at a time, never actually arrive. But 0.9 repeating isn't one of the steps. It is the wall those steps are racing toward, the destination itself. Now, let's make a proof you can literally watch. Spell 0.9 repeating out in full, and it's an endless sum, 9/10 plus 9/100 plus 9,000ths, on and on without end. So picture filling a bar that represents 1. First lay down 9/10 of it. Then 9/10 of the thin sliver that's left. Then 9/10 of that, each step erasing most of the gap that remains. Watch carefully what happens to the leftover. It shrinks and shrinks and shrinks toward nothing. No sliver, however thin, survives forever. Every part of the bar eventually gets covered. It fills completely. And the exact total isn't guesswork. There's a clean formula for a shrinking sum like this. The first term divided by 1 minus the ratio. Here that's 0.9 over 1 minus 0.1. 1 minus 0.1 is 0.9, so it's 0.9 over 0.9, which is exactly 1. The infinite sum of all those nines lands precisely, perfectly, on 1. So why does a truth with 3 proofs still feel so wrong? Because we instinctively imagine writing those nines down by hand, one at a time, and obviously never, ever reaching the end of the list. But the infinity here isn't a chore that you fail to finish. It's a finished, completed whole. Every one of those nines is already in place, all of them at once, the moment you write the dots. And the real numbers themselves leave no room for a leftover gap. There is no smallest positive number, no tiniest possible sliver you could ever wedge in between the nines and 1. The space simply isn't there. So the discomfort you feel is really just our small, finite minds bumping up against a genuinely infinite object. The mathematics is perfectly clean. It's the uneasy feeling that's the illusion. Now here's the genuinely reassuring part. None of this is a glitch or a loophole in the nines. It's just that plenty of perfectly ordinary numbers happen to have 2 different decimal names. 1/2, for instance, is 0.5, but it is equally 0.499 repeating. 2.8 is also 2.79 repeating. Every decimal that terminates has a repeating nines twin. And this is no stranger than fractions, really. 1/2 and 2/4 are the very same number written 2 different ways, and that little fact has never once kept you awake at night. The deep reason is that a point on the number line doesn't care how we choose to spell it. Decimals are just labels we paste on. The number itself is the location they point at. So 0.9 repeating equals 1 isn't a paradox lurking in mathematics at all. It's simply a built-in feature of the system we use to write numbers down in base 10. Now one genuinely honest footnote for the sticklers in the audience. Everything we've just done lives inside the standard real numbers, the ordinary ones you measure with, count with, and use every day. There do exist stranger, more exotic number systems, ones that include so-called infinitesimals, numbers smaller than any fraction yet bigger than 0, where you genuinely can construct a tiny, non-zero gap. But standard decimal notation has no infinitesimals in it. In the ordinary real numbers, the ones decimals are built for, there is simply nowhere for such a gap to live. The room for it doesn't exist. So when someone protests that the nines are only infinitely close to 1 in the real numbers, infinitely close is not a near miss. Infinitely close means equal. Full stop. So there it is. 3 completely different roads, the pizza, the line of algebra, and the hunt for a missing gap, every one of them arriving at exactly the same place, 0.9 repeating equals 1. And the real lesson runs deeper than this one quirky equation. A number and the particular way we choose to write it down are not the same thing. Sometimes a single number simply wears 2 different names. As for that uneasy feeling you started with, don't be too quick to throw it away. That's infinity itself, politely refusing to fit inside a finite human head. Keep that feeling, the discomfort is the whole fun.